All right, so let's implement insertion sort. I've already created a project. I'll be putting code into academy.learnprogramming.insertion sort. I've added the usual array and code to print the array. And this implementation doesn't need the swap method. We don't swap, we shift elements. And so I have not added the swap method because we don't need it. Okay, so let's get going. So we'll say for int first unsorted index equals 1, because remember, this implementation starts out by assuming that the element at position 0 is in the sorted partition. And so the first unsorted index will start at 1. And then we're going to keep going as long as the first unsorted index is less than the length of the array. So we're going to examine all the elements right up to the end of the array. And after each iteration, the first unsorted index will be incremented by 1 because we're growing the sorted partition from left to right. And so the first unsorted index is going to be increasing by 1 after every iteration. Okay, so the first thing we're going to do is save the value of the element we're going to insert into new element, because as you saw in the slides, when we do the shifting, that position, the element, is going to be overwritten. And so we need to save the value off. So we're going to save off int array first unsorted index. And I'm going to declare I outside the loop because I need it after the loop. And now we're going to code the loop that does the traversal of the sorted partition and looks for the correct position to insert new element. So we're going to say for I equals first unsorted index, because when we start out, the element we want to insert is at first unsorted index. And we're going to continue to loop. In other words, we're going to continue to look and keep shifting items as long as I is greater than 0, because that means we haven't hit the front of the array. And we'll keep going as long as whatever is at int array I minus 1 is greater than new element. So what is this doing? Just to go over this again, we want to keep looking for the insertion position as long as we haven't hit the front of the array, because if we hit the front of the array, it means that the element we're trying to insert is the smallest element we've seen so far, and the correct insertion position is 0. And we want to keep looking as long as the element we're looking at in the sorted partition is greater than the one we're trying to insert. Because if the element at I minus 1 is greater than the element we're trying to insert, then we still haven't found the correct insertion position. So the moment we hit the front of the array, or the moment we hit an element that is less than or equal to the element we're trying to insert, we have found the correct insertion position. And on each iteration, we're going to decrement I, because remember, we are traversing the sorted partition and doing the comparisons from right to left. And so we're moving down the sorted partition. Okay, so what do we want to do if we haven't hit the front of the array and if the element at I minus 1 is greater than the element we're inserting? Well, if that's the case, we want to shift the element at I minus 1 to the right, because we need to make room for this new element. So what we're going to do is we're going to assign int array I with int array I minus 1. And so this is where we're doing the shifting. We're shifting from left to right. So for example, when we want to insert minus 15, assume we've done the first iteration and 20 and 35 are in the sorted partition. When we want to insert minus 15, the first unsorted index will be 2. So I will be 2. So we'll say, is I greater than 0? Yes, it is. Is the value at int array I minus 1, which is 35, is that greater than minus 15? Well, yes, it is. So this condition is met. And so what we're going to do is we're going to assign int array 2 with int array I minus 1, which is int array 1. So we're effectively going to assign 35 to position 2. And you saw this in the slides. So if you're having trouble understanding what's going on here, go ahead and look at the slides. And then we'll decrement I to 1, And so on the second iteration, we'll say, is I greater than 0? Well, yes, it is, because it's 1. And we'll say, is int array 1 minus 1, which is int array 0, is that greater than the new element? Well, yes, it is, because 20 is greater than minus 15. And so we're going to shift 20 to the right. So we're going to say that int array 1 is equal to int array 1 minus 1, which is 0. So 20 will get assigned to position 1. And then we're going to loop around and subtract 1 from I. And at this point, I will be 0. So we'll say, is I greater than 0? Well, no, it's not. So we'll drop out of the loop because we've hit the front of the array. Now, when we find the correct position, what do we need to do? Well, our final step when we drop out of this loop is to assign int array I with new element. So in the case we just looked at, when we drop out of the loop, I is 0. And so we're going to assign minus 15 to int array 0. And that's exactly what we want. It'll put minus 15 at the front, and we've shifted 20 and 35 over 1. And so that's how this implementation works. And we have finished coding the implementation. And so the outer loop is the one that's growing the sorted partition by 1, and the inner loop is the one that's looking for the correct position to insert each element and is doing the shifting. So let's run this to make sure this actually works. And indeed it does. We get minus 22, minus 15, 1, 7, 20, 35, and 55. I'll just close that off, and so that is insertion sort. It works by taking each element and inserting it into its correct position in the sorted partition, and at the end, when we've gone through all the elements, the entire array is the sorted partition. And so we're done. Okay, now as you can imagine, sometimes this will involve a lot of shifting. For example, I guess I should remove that comma there, I'll do that. For example, in our array, the smallest value in the array is right at the end of the array. So when we finally hit minus 22, we're going to have to do a lot of shifting. We're going to have to shift every other element in the array to the right to make room for minus 22. There can be a lot of shifting with this algorithm, and so perhaps there's a way to improve this algorithm, and there is, and we're going to look at that in the next video. I'll see you there.